logarithm is. So a logarithm is very closely related to the exponential. I'm going to keep yawning. Just like with exponentials, we had to have a base, a positive base bigger than, or that wasn't 1 itself. And the logarithm, y equals log base a of x, means the same thing as x equals a to the y power.
Same thing? Okay.
So what this means, a logarithm can always be written as an exponential. The base of the log is the exact same as the base of the exponential.
Oh, I remember this.
And then you go across the equal sign. So we're saying a to the y power equals x. A logarithm is essentially finding a missing exponent. When I say log base a of x, it's saying a to some power equals x. Find that power. With exponentials, we know if we take a positive number to a power, we get a positive answer. So the domain, the argument on here, always has to be greater than 0. And that will be very important later on in this section.
Oh, so you have coffee, but we can't get coffee.
I have water.
Yeah.
No wonder you're tired.
Drinking water. Okay. So let's practice going back and forth between the two. So if I wanted to write 1.2 to the third power equals m in exponential form, or sorry, in logarithm form, we put log, log. The base is 1.2. That is a subscript. So it's not a log with a full-size 1.2 beside it. It's a subscript down to the side of m. M is a regular size number, equals 3. Right, B. If I wanted to write this one, did you get it?
Yep.
In exponential form, you start with the base. So the base is e to the negative third power equals b. You guys try C and D. So what's the answer to C?
3c equals 5.
3 to the C power equals 5. And D?
Log base of 3, g equals 2.
It's actually a 9, not a G, but
Oh, oops. 9.
all right.
Actually, been in minus section, so we're all good.
Okay,
No longer
glad.
distracted.
It's because you have chocolate now. That makes it better. So let's find the exact value.
Oh, no.
We have two options for these. Some people can look at them and know the answer. If you know what a log is, that's pretty easy to tell. A log is an exponent. When I see this, it's like saying 2 to what power equals 16? So the answer is 4. If you don't see that, just set it equal to x and change it to exponential form. 2 to the x power equals 16. Didn't we just do problems like this on our test? Common base. And you get 4. I don't care whether you show work or not. B, log base 3 of 1 over 27. That's saying 3 to what power would equal 1 over 27? C, log base 2 of 1. That says 2 to what power equals 1?
0.
D, log base 5 of 25. Says 5 to what power equals 25? Is everybody okay with just looking at those and giving an answer? All right. So let's solve for other parts in these equations. So if I ask you to solve log base 3 of 4x minus 7 equals 2. Close. You flipped them. Start with the base. So it'd be 3.
4x minus,
Okay.
oh, but I
3
see.
squared is 9. Divide by 4, so we get x equals 4. You do need to check on these. Both the base and the argument have to be positive. If you get a negative for either of those, you have to say no solution. So just quick check, if I plug 4 in, 16 minus 7 is positive, so it's all good. B. Log base x of 64 equals 2. So what would we write?
X is, yep,
Well, I mean, square root.
Right. When you add a square root, you do plus and minus, but the base has to be a positive number. So our only answer is positive 8. When you add the square root, you have to do plus and minus. So we actually get plus and minus 8.
alright, the number has to be greater than 0.
But the argument and the base have to be positive. The only thing that can be negative is what it's equal to. The whole thing can equal a negative number. So like this could be a negative 2 over here. That's all right. But the things with the log both have to be positive. So we throw out the negative 8.
Okay, okay.
And if one of them is negative, no solution.
Mm-hmm.
Okay.
Let's try some more. All right. What would I write for A?
X is negative.
Then how would you go about solving that? Okay. Get rid of square root, plus and minus. So we get plus and minus 3/4. Are both of those possible? This is my base. The base has to be a positive number. So 3/4 is the only answer. Why don't you guys see if you can figure out the next two?
I cannot wait for the final issue.
We're gonna go over so much stuff.
Not so bad.
It's just refreshing your memory.
Mhm. We will review. I want you to just walk into your final without me. Okay, so 4 third to 16 is 2, 2 to the third is 8. You guys get that?
Nope.
Alright, this says 36 to the x power equals the square root of 6. So my common base would be 2. 36 is 6 squared. The square root of 6 is 6 to the 1/2. So you have 2x equals 1/2. So x is 1/4. And last one, 2 to the third power equals 2x plus 1. That would be 8, subtract your 1 over, so we get 7/2. Is it okay? Alright. So I wanted to talk briefly about your calculator. If you take a look, there are log buttons that we can use. When you're looking at the calculator, on the left-hand side above your on button, you have
Don't we use ln?
a log and we have an ln button. Log is just a base 10. So on these, I'll have it in base 10 so you can put it in this calculator. So if I ask you to do log of 46, You push that log button, it opens your parentheses, you put your 46, and you get 1.6628. Natural log is actually a log-based E, and we will talk more about that later, but right now I just want to make sure you know how to plug it in. So a lot of times this will be written in scientific notation with E's in it. So we do the LN, and then we have 8 times, the E button is second natural log to the 6th power. So we can use our calculator for special logs. I'm not going to lie to you and tell you you can't do others on your calculator, because you can go into the functions and get where you can change the base. But I will be very specific on which ones you can and cannot do on the calculator. And just the calculator itself doesn't solve equations, so it won't be helpful most of the time. All right, last thing that we need to talk about today are properties of logs.
When it comes to writing those down in fourth decimal place,
Yeah. Okay. First one is the product property. It says if you have log base A of x times y, so if you have the log of two things multiplied together, you can break them apart and add their individual logs. Do you guys know where this comes from?
Probably some dude.
Think about your exponents. If I said like 2 to the x times 2 to the x plus 3, when you multiply those, what do you do with your exponents? Add them. So when logs are added, that's the same thing as multiplying their arguments. It's all related to the exponents. So if I have log of x divided by y, think about exponents. When you have things divided, what do you do with your exponents? Subtract them. So in this case, we subtract the logs. Third property, if you have an exponent, you can actually bring that down as a coefficient on your log. The last two properties that we're going to use don't really have names, but they have to do with the fact that the exponential and log are so closely related. So we are going to find out as we deal more with our logs. Logs and exponentials are actually inverses of one another. Okay, they just reverse the x and y, they're opposites. So what happens if you do both a function and its inverse?
the domain and the range, or are you talking something?
I'm talking like, so give me a number.
1.
1. So if I add 5, and then what's the inverse of adding 5? Subtract 5. So if I do 1 plus 5 minus 5, what do we get out? 1. If you do both the operation and its inverse, those cancel and you get what you started with. So if I do both the exponential with the base of a and the log with the base of a, the exponential and base part, the bases cancel, and you just get your argument, what you were doing the log of. And it works in reverse too. if I have the log, then the log base A and the A part cancel, and we just get that exponent. And we'll talk more about these properties. We're going to use them a little bit today, but we're going to start here on Monday and deal with them a lot more. So I'm going to put a couple problems up, and I want you to see if you can figure out what the answer is. Let's say, what did you guys do? Yeah, if you realize the base of the exponential and the base of the log are the same,
It's 8.
those can cancel and give you 8. This one, I saw two different approaches when I walked around. Some of you recognized these bases were the same, so they cancel and just give you the negative radical 2. Others did the property where exponents come down in front. So you have negative radical 2 times this log. This is saying 0.2 to what power equals 0.2? 1. And you get the same thing. So either way, negative radical 2. Two different ways to think about it. How'd you guys do 3?
You need a common base.
Okay. So, okay. So 2 ways, and I'll talk through both of them. If you move the 1/3 down. So we have 1/3. Log base 4 of 16 says 4 to what power equals 16? 2. And you get 2/3. The other way of doing it is to say, well, 16 is 4 squared. So this is 4 to the 2/3 power. So these really cancel and you get 2/3. Two ways of thinking about it, same answer either way. Okay, so I am done. There is a handout posted on Classroom.